All right, so again, 7.4 is properties of special parallelograms. We are narrowing down further into rectangle, rhombus, and square. So a rectangle, by definition, is a parallelogram with 4 right angles. A rhombus is a parallelogram with 4 congruent sides. And a square is like if a rectangle and a rhombus had a baby. It has 4 right angles and 4 congruent sides. So they still have all the properties of a parallelogram, which means in each of them, opposite sides are still congruent, opposite angles are still congruent, consecutive are still supplementary, and diagonals still bisect each other. All that stuff still applies. It's just now it's even more specific. Mars. Wait, let me. All right, so then based on the definitions, there are 3 corollaries. Remember, like corollaries is just something that's easily determined from what we know about these shapes. So this says a rhombus corollary says that a quadrilateral is a rhombus if and only if it has 4 congruent sides. And this means both directions. So if it has 4 congruent sides, it is a rhombus. And if it is a rhombus, it has 4 congruent sides. The rectangle corollary says the same thing, except it's about right angles. So if a quadrilateral is a rectangle, if and only if it has 4 right angles. If it has 4 right angles, it's a rectangle. If it's a rectangle, it has 4 right angles. And the square is both. A quadrilateral is a square if and only if it is a rhombus and a rectangle. So this gets tricky when you start to get into always, sometimes, never questions on these. For example, a square is blank a rhombus. Square is always a rhombus. A rhombus is blank a square. Sometimes. A rhombus is blank a square. If it's a rhombus with 4 right angles, it's still a rhombus, right? But now it's a square. So if on like level with it, a rhombus can sometimes be a rectangle. It can sometimes be a square. A rectangle can sometimes be a rhombus, and a rectangle can sometimes be a square. A square is always both, because a square is more specific, okay? There are things that can never be never. It could never be a triangle, but for these, a square would never be neither. Yeah. Yeah.
So
pausing. Okay, so this is a Venn diagram if you need the visual on it, okay? So in the big box are the parallelograms. If we even went out further, we could say quadrilaterals because within the quadrilateral is the parallelogram. Parallelograms just have to have 2 pairs of parallel sides. If we then make it more specific and say it's a parallelogram with 4 congruent sides, that's the blue side, which is the rhombus. If we said it's a parallelogram with the 4 congruent angles, or 4 right angles, that's the pink side, which is the rectangle, and then the cross between them is the square. So eventually we're going to learn some more properties about these, and you want to figure out like what properties apply to what. So try to keep this visual in your head. So the first says a parallelogram is a rhombus if and only if its diagonals are perpendicular. So rhombus has diagonals that are perpendicular. They bisect each other, but they are also perpendicular. That means where they meet is a right angle. So this would be true for a rhombus and also a what? A square. A rhombus and also a square. It's sometimes true for a parallelogram. It's sometimes true for a rectangle. But it is always true for a rhombus. And if it's always true for a rhombus, it's always true for a square. All right, second property says a parallelogram is a rhombus if and only if each diagonal bisects the pair of opposite angles. So rhombus has diagonals that bisect each pair of opposite angles, which means each of the angles in these corners are divided into 2 congruent parts if it is a rhombus and also if it is a square. So everything that's true for a rhombus is also true for a square. And then the last one says a parallelogram is a rectangle if and only if the diagonals are congruent. So a rectangle has diagonals that are congruent.
A rectangle is a parallelogram?
By definition, a rectangle is a parallelogram that has 4 right angles.
Yep. But a rectangle is not a rhombus.
It could be.
It could also be a square.
Yeah, because a square is both, right?
So a rectangle is everything?
No, a square is everything.
A
square is a square, a square is a rectangle, a square is a rhombus.
Oh no, but a rectangle can't be a rhombus. It can only be a
It
parallel.
can be. If a rectangle is a rhombus, now it's a square.
Yeah. So whatever.
Just think about it like anyone can be anything.
So because it's true for a rectangle, it's also always true for what? If it's true that the diagonals are congruent for a rectangle, what else always has congruent diagonals? A square. So if it's true for a rhombus, it's true for a square. If it's true for a rectangle, it's true for a square. Okay, so what's true about every quadrilateral? Let's start with that.
4 sides.
4 sides.
4 angles.
4 angles. What's true about the sum of all the angles in a quadrilateral? Add up to 360. Then we get more narrow and we start talking about parallelograms. So what do we know about parallelograms?
Opposite sides are parallel.
Opposite sides are parallel.
But not all sides are congruent.
Nope. What else do you know about a parallelogram? Remember, there's 5 things you know about a parallelogram.
Oh, the opposite angles are
Opposite angles are
congruent.
congruent. What else?
Opposite sides are congruent.
Opposite sides are congruent. What else?
Diagonals bisect each other.
And the last thing?
It's like the parallel, like one side parallel and the other one's.
That's to prove it. So you're flipping it. Yeah. It's something about the angles.
Oh, wait.
Kumar. We got that one.
Oh,
Yep.
consecutive angles are something.
Good. So because that's true for every parallelogram, because those are true for every parallelogram, all those properties are also true for everything below it, right? So then we just added a rhombus, has 4 congruent sides, and we added 2 properties about a rhombus, which are what? We just added it on the last slide.
Wait. What's the question?
We added 2 more properties about a rhombus.
Alright,
Definition says
a parallelogram is a rhombus if and only if its diagonals are perpendicular.
diagonals are perpendicular.
And all the sides are congruent.
Diagonals are perpendicular and
And all the sides are congruent.
we already have that. And the diagonals bisect opposite angles. Okay. So if that's true for a rhombus, it's also true for a square. Then we learned about what for the rectangles. We added 1 property for rectangles. Yep.
The diagonals are congruent.
Diagonals are congruent. So if they are congruent for a rectangle, they are also congruent for a square. So everything on this slide, when asked, like, could this, like, it is blank this property, if it's not in the circle with it, then it's sometimes. If it is in the circle with it, then it is always. But if it is like, so like in a rectangle, like in a parallelogram, are diagonals congruent? They are sometimes congruent because they are true all the time for rectangles and squares, but they are only sometimes true for parallelograms. So you have to know these properties so well that obviously you can apply them to these shapes, but you also have to know how to apply them to the always, sometimes, never questions. All right. So example 1 says quadrilateral ABCD is a rhombus. Find the measures of each angle. So what do we know about the angles in a rhombus?
That each side adds up to 180. That congruent angles add up to 180.
What? Congruent angles add up to 180.
What are we trying to do here?
We gotta find like all the angles.
Okay.
So we have to find angle. This is angle 1.
Obviously, angle A is also so it's easy too.
EDC 3 and ABC. We're trying to find all 4 of those angles. Okay. Obviously, what were you saying?
62 on the A to the right of the A is also 62.
This one
Yeah.
is also 62.
ACD is also 62.
ACD is also, wait, ACD is also 62 because in a rhombus, diagonals are bisected. Good. So we have that one. That's one, the first one.
Since A adds up to 124,
A has,
we know that B adds up to 56.
How do you know that?
The angles are supplementary when
Good.
they're consecutive,
Good. So 4 is 56.
which means that ABD and DBC are both 28 because they bisect,
Good. So this would be 28 and 28.
which means that the other angles on the opposite side are also 28.
28 and 28. And now we have that one.
And 2 is 90 because they meet at, what's it called?
They're perpendicular.
Good job, Kala. They are also perpendicular. Okay. Which, and you could have also, like, once you found this triangle, you had 2 of those angles that you can also add together and subtract from 180, but the 90 is obviously faster if you can get it that way. Kumar.
because you add 28 to 28.
That's not how we got it, though. Thank you very much, Santi, but that's not how we got it.
No, I know why, because.
She said if each of these are 62, right, then this whole angle is 124. And then these angles are consecutive, which means they're supplementary.
And they're 56.
So if you subtract 180, if you do 180 minus 124, you get 56, which is this whole angle.
That's what I was trying to say.
Oh, I'm so sorry. I misunderstood.
Wait,
Yeah,
I have a
so-
question.
We looked at as is. We also know that these are 90 degrees, right? 90, 90, 90. So this is 90 degrees. Then I could have found this angle by doing 90 minus 32.
Wait, why 32?
I mean 62. Sorry, 62. 62, which is 28. Right? Because individually there's 4 right triangles there.
Oh, there's 4 triangles.
Yep, and they have to be right triangles because it's a rhombus, and a rhombus, the diagonals are perpendicular.
And it doesn't look like you're right triangle.
Thank you for sharing.
So, like, angle CAB
Mm-hmm.
and angle DBC, they would equal 90, right?
No. You mean if you added them together?
Yeah,
Yes.
that's one.
Yes.
Always?
Always. In a rhombus or a square. All right, quadrilateral NMOP is a rectangle. Complete the following. So what do we know about a rectangle? This one has sides and angles. What do we know about the sides of a rectangle?
Well, the sides.
Diagonals are
Opposite are congruent and diagonals are congruent. So this one equals this one. And the angles, what do we know about the 4 big angles, like angle M, angle N, like those 4 corners? They're all 90. So PON, which is the big angle right here, we just said was 90 degrees. PMO, which is this smaller angle here. How do I find that?
90 minus 29.
Good.
AKA 61.
PL is this part of my diagonal.
So it's also 12.
Good. And that's not just because it's a rectangle, that's because it's a parallelogram, right?
And then MO is 20 to
44.
Good.
because you add them together, so you.
And then it'd be congruent.
Overall.
Questions on that one? All right. Quadrilateral, M-O-R-E, is a square. So now it has all the things. It's got opposite sides. All the sides are congruent. It's got the diagonals are congruent. It's got the diagonals are perpendicular. It's got the diagonals bisect the angles. The angles are 90, which means those diagonals split into all 45-degree angles. So when it says ME is 7x minus 3 and MO is 6x, what do we know about those two sides? They're equal to each other. So 6x equals 7x minus 3. Subtract the 7x and I get negative x equals negative 3, which means x would equal 3. And again, you can only do that on a rhombus or a square. You couldn't do that with a rectangle.
Wait, why is the
Why are you yelling at me?
Why is the parentheses?
Because you got to get rid of the x. You can either divide or multiply by a negative, but I was multiplying the whole thing by a negative. That's what that was.
Oh.
Yeah. All right, then B says MT, which is half of my diagonal, is 4x, and TE is 3x plus 2. What's true about those? They're equal because the two full diagonals are congruent, right? And then you cut two congruent diagonals in half, making them also congruent. So 3x plus 2 equals 4x. Subtract the 3x. 2 equals x. And that's x, but it's asking for OE. So I'm going to plug the 2 back in. I get 6 plus 2, which is 8. That's from E to T. So the whole thing would be double that 8. Good. Yep.
MT would be equal to TR.
MT would be equal to TR, correct.
So all the segments are.
In a square.
Yeah.
In a square because it has diagonals that are bisected and also congruent. So in a square and a rectangle.
So all the segments are congruent.
Inside.
It's equal.
In the square.
All the ones inside are equal to each other and all the ones on the outside are equal to each other. Yep.
There's 90-degree angles.
And those are four 45, 45, 90 triangles. Because where they meet is 90 degrees. And then they're congruent. This would be congruent to this, which means it's 45, 45, 90. Each of those. There's little